This is how our robot is mounted on our clipboard, and this is a demonstration of its range. So as you can see, it can go outside of the clipboard, and it covers a pretty good area and range of our whiteboard that we have clipped onto it. So our mounting position allows us to have a pretty good range with our robot. So this is our GUI. In the top of our GUI are axes for drawing the grid, and then also the moves that are made during the tic-tac-toe game. Down here we have our game board, which tracks which moves were made in which position of the grid. Buttons for going to a specific box of our grid. Buttons for moving the end effector, which has the pen, either up or down. Drawing the tic-tac-toe grid, drawing X's and O's, and then also starting or restarting the game. We also have menu options for initializing the Arduino and the servos. So I'm going to show these working before we go into the demonstration of the game. So for the Arduino one, it will pull up a dialog box for the user to import the port number for the Arduino. But for us, we just have it set to default to COM13 since that's the port we need to be using. So I'm going to hit OK on this. So this confirms to the user that the Arduino connected successfully. And then now for the servos, it will ask the user to input the pins that the servos are connected to. And then once they're ready, they can hit OK. And these are the defaults for us because this is the pins that our servos are connected to. So it also confirms that all the servos are connected successfully. Now I will show our GUI working with the hardware to be able to draw the grid, move the pen up or down, move the robot to a specific position in the grid, and then also play the game. So first, this is going to be drawing the grid. It's not perfect, but good enough. And then once it's finished drawing the grid, it will just confirm to the user that it's ready for more options. So now I will show the robot moving to the different positions of the grid. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. We can also see that in the axes here, it does label all of these points. And the points that it goes to are specifically roughly about the center of each box. So now I will show the pen moving up and down. So here's our pen. This is it moving down and back up. Now I will show the robot playing the tic-tac-toe game. So first, I am the first player, so I'm going to choose a position to start. So I will start at position 2, and then I will just click the X once I'm ready. After, the robot thinks about its move, and it chooses what it wants to do. It uses ChatGPT to figure out which move it can make, and it always strives to pick the best move first. So now we keep playing the game. So because AI is implemented into this, it will always, again, choose the best move, but always prevent me from winning as well. So we can predict that its next move will be in position 3 right here. And we are correct. Now we can just keep playing the game. I'm going to prevent it from winning by completing that diagonal there, so I will just put an X there. So this is at the conclusion of the game. So me and the robot tied. So it shows who won or who lost in this box here. So the last thing to show is our extra credit code. So it takes a little while to run, so I'm not going to do another one, but this is one of the tests that we did. So this is basically ChatGPT versus Minimax in tic-tac-toe and seeing which one performs better. So the code will run through 5 games in total just to see which one does better. So the result of the first game was a tie, the second was also a tie, and the third was a tie. And fourth, Minimax won, and then fifth was also a tie. So the final results are shown down here. And overall, Minimax does better than ChatGPT, which makes sense because Minimax is, basically picking the most perfect moves they can, while ChatGPT is just a bit weaker in that respect. So that covers the extra credit portion, comparing the two models essentially.